2. Welcome to Chapter 2, the DMAIC or Six Sigma methodology. I would like to welcome all of you to our second chapter in this course. And we are going to cover a different material than the textbook, since I reviewed the textbook material and I found it's not enough for the Six Sigma methodology. So I'm going to use an extra material. Is not going to be contradicting with the information in the textbook. It is going to be further information, and it will help you to understand the methodology better and implement it if you are going to plan to have a Six Sigma in your capstone project, or even after you graduate, you will be able to use it using the material that inshallah we will cover during this week. Checking on voice, just I would like to make sure that the voice is clear to everyone. So please, can you write me in the chat box? Good. Okay. We will have the questions at the end of the session. So please write your questions and the slide number, and we will cover all the questions at the end. So we will have enough time to answer all questions. Let's start with the Six Sigma methodology. And what is the Six Sigma methodology? The Six Sigma methodology, it's a discipline or business methodology, increase the customer satisfaction and reduce variability, which is found to be or equivalent to defects in the process, to improve the process control and overall quality in the process. The Six Sigma usually start with the practical problem. What does it mean, the practical problem? That means there is a problem or an issue in the process or at any given organization. This practical problem, it is converted to statistical problem using statistical tools like gathering data and using statistical analysis. Then statistical problem will be converted to statistical solutions using also statistical tools like design of experiments or control charts or other tools that help you to find the statistical solutions you need to apply. That statistical solution changed or converted to a practical solution where the process has to be adapted to these changes to fulfill the statistical solution or to perform under the new statistical solution. Then you develop a control plan to make sure that solution you have proposed, it can be monitored and then it can be maintained. At the end, the results can be measured over the time, and that process, it's a continuous process, since the control usually it is ongoing process. That's why the process of the DMAIC or the Six Sigma start with the defining the problem, then measuring the problem, analyze it, then improve it, then the control. And the control usually it is ongoing, so the control goes to the define again if there is any issue and measure, analyze, improve, control. But not every time you do it, that means you have to change the process over and over. Sometimes within this phase, you have just to adopt small modifications, but everything will be the same in the process. The Six Sigma roles and responsibilities, and I have heard some of the students in the last time has questions or has participated in the classroom talking about the black belts and the green belts of the Six Sigma. Here we will demonstrate what are the roles and responsibilities on for a Six Sigma project. Now, depend on how big the project, the roles here of those responsibles, it will be varied. Sometimes two jobs will be combined together under one name, or even sometimes three, but this is the ideal situation. What is going to be required from you, you have to identify what is the role for each one. For example, if I ask you, what is the role of the project sponsor? What is the role of the black belt? What does mean the awareness or the white belt training? What does it mean? That means all the employees going to have the Six Sigma project implemented in their organization, they have to be aware so they can collaborate to achieve the goal of the project. Starting the roles with the leadership, comparing that to our university, for example, if we want to apply it, this is like the president or the VP of the university under the organization leadership. They own the vision, they develop the vision of the company or the organization, as well as the vision of the project results, the direction, they acquire or they need executive training. The things here in the red font, that's mean the requirements for this position or this role. Then the deployment champions, they call it the champions. The champions who lead the efforts within the department, prioritize the projects, because as I told you, sometimes the Six Sigma project is very big and it contains different sub-projects underneath it, because each project or each sub-project is targeting a certain process in the organization. So the champion, he is the one prioritizing which project should start first and manage the project's portfolio. Also, he needs executive training as well as sponsor training, how to maintain or manage those projects. Then after the champions, we have the sponsors, and the sponsors who they are the project owner, and that is going to be for each project there is a project sponsor, not like the champion. The champion, he leads all the projects. Then we have the project or the process manager. The process manager, he's the one responsible from the organization as a supervisor. He's the technical person. He's the one who knows the process the most, comparing to others. I compare this one here as the department chairman in the college. The project sponsor, it can be the dean or the vice dean. The champions, it can be the deanship for quality in the university. The project team members who are going to be working in the team, it could be people not from the organization. It could be people as a part-time job. They work in this project to gather the information, to analyze it, to suggest the improvement, but they should be working with those people here hand to hand to understand the process if they are from outside. Those people, they need the yellow belt training so they can perform in the team as a team members. The green belts, those people, they lead project in terms of the team, not leading the project in terms of the goals and the portfolio. Those people, they can leading those team members, and those two, the green belts, the project team members, sometimes they can be merged together and be in one unit. Those people, they need a green belt certificate, or they already finished a green belt training to be eligible for that. The black belt comes on the team as a coaching, so they coach those team members, and the green belt. The master black belt coach all the black belt in all the projects, because those the subject expertise about the Six Sigma. Those people more of from the organization expertise, as I told you, like a dean or chairman or vice dean or deanship of quality. But the other side here, when you see the belts, the master black belt, the black belt, and the green belt, those people, they could be even sometimes outside the organization, but they are very expert in the Six Sigma. Some companies, they develop a position of master black belt in their organization, like General Electric. They do have master black belt position in their company, because those people, they run Six Sigma methodology projects over the time in their organization. Now, this is, it can be varied, depend on the culture. depend on the organization objectives, but the roles for those members. So all what you need to know, what is the differences between them, what is the job requirements as specified here. All the other employees in the organization, they need to be aware of what is Six Sigma, and the awareness level is like the level you are going to achieve here after finishing this chapter. This is the level they need to know about Six Sigma, and they consider that as a white belt. So you can say that after you finish this course, you are aware about Six Sigma, and you have the, let's say, the white belt level, even though it's not certified, but you already covered the material about Six Sigma. They apply the concept to their job, and they understand the vision of the projects that are going to be implemented in the organization. Now, the classical view of performance for Six Sigma, it's talking about how is the 99% that is not acceptable performance level anymore. When we talked in the last lecture, many students, they said that 99% is very good, and it is well done if you are performing under 99%. Well, to tell you the truth, if you are performing at 99%, that's mean you will have 20,000 lost articles of mail per hour. That's mean every hour in, let's say, DHL, UPS, or Saudi Post, they will have every hour 20,000 lost items in the mail. You will have 15 minutes of unsafe drinking water every day. That's mean you are going to drink unsafe water every day, or you will be exposed to this risk. 5,000 incorrect surgical operation per week. Imagine if a hospital will have this amount of mistakes in surgical operations. You will have 200,000 wrong drug prescriptions each year. That means you will go to the doctor, he will give you the wrong medicine. 200,000 each year. How many people could be harmed by this number? No electricity for almost 7 hours each month. We have sometimes shortage in electricity in general, but this is like comes maybe yearly, and it never lasts more than a couple of minutes. So imagine every month you have 7 hours of no electricity. This is a 99% performance level. So again, if I direct the question to you, or is 99% is acceptable level of quality? Are you still convinced that the 99% is perfect performance? After you see the practical meaning of the 99 based on the statistical analysis, I think you will have a different point of view about the 99%. As a matter of fact, the historical standards of quality, historical standards, I'm talking about 80s, after the World War II, in 70 to 80s, that is the time where was even the 93% and 32 is the acceptable level for quality that time. The current standards nowadays, if you are not performing under 99.38%, you are not going to survive in the market. You are going to be shutting down your business because of the number of complaints that you will receive from consumers and customers. Now, the current standard, that means it is a must, is not something preferred, is not meaning that they are going to meet your expectation. They have to maintain 99.38 to maintain the current standards level, which is the 4 Sigma. But the new standard, where is more organization working to achieve, which is the 6 Sigma level, the 99.9999%. And that leads to 3.4 defect only per million opportunity. What does it mean? Per million opportunity, that's mean if you are repeating the step, whereas the defect can be appeared million times, you will have only 3 times defect. So this number will definitely reduce to almost nothing compared to what you have seen it under the 99%. To give more picture or better view about that, let's see this table. This is the sigma level here on the left column, and here is the defect per million opportunity. And at the 6 sigma level, you will have only 3 defect per million or 3.4 defect per million opportunity. Where when you have the 99%, when you go to the 99%, this is the closest to 99 here, 98.9 or the 99.18. That will lead around 8,000 to 10,000 defect per million opportunity. See how much is the difference when you perform at 3.8 or 3.9 sigma level comparing to 6 sigma level. This is what all organizations trying to achieve. This is a historical level of performance. If you are performing 3.9 and below, you have to maintain 4 sigma level or above to be survive in the current market quality level. How is the Six Sigma benefiting? There are many examples, those just for your information. Those big name companies like General Electric has done benefiting from Six Sigma by reducing 62% of waste reduction. Some people, they improve or reduce the shipment time or the shipping time from 18 months to 8 months. That's cutting almost to half, reducing or reduction in the expenditure cost by 2.45 millions, like in Dow Chemical. In the slide of the PowerPoint, you will have a better view for this slide that will be posted later. This slide only for your information, just to understand how Six Sigma project succeeded in the implementation. This is to show you how is the difference between the 3 Sigma level and the 6 Sigma level. When you are performing at 3 Sigma level, this is the bell shape or the normal distribution shape that you will have, and that will give you no more for room to perform above or below, above the upper limit or above the specifications limit, because you are, most of your readings will be just close to the specification limits. Where here in the Six Sigma level, you have most of the reading away from the specification limits. That will give you a room for freedom. Even if you perform here, you are still going to meet to be below the specification limits, and you, as much you be away from the specification limits, that means the customers are satisfied. As when I give you example, if the waiting time for a food order to home using one of the applications like hunger stations or any other applications or any other restaurants, if you order food to home, maybe the average time is acceptable to you or the specification limits does not exceed 40 minutes. If the food arrived in 10 minutes, that means you are here in this area. If you are receiving food 5 to 10 minutes, but every time if you are like at 42 or 43 or 40 minutes, you will be almost here on the tight region, because the Sigma level here, there is a tight room to be away from the specification, whereas here you have a wide room to move around the specification limits. Moving to the DMAIC process, the DMAIC process is, as we say, that it stands for define, measure, analyze, improve, and we will start with the define. We will cover the define, measure today, and part of the analyze. Then we will have open the time for all the questions, and we will continue the remaining phases on the next class. The define phase is capturing the voice of customers, and the customers, as I said, whether the customers internally or externally, that working on the process, or benefiting from that process. How we collect the voice of customers? We can use surveys, interviews, focus groups, suggestions from the customers, observations. That means you are on the process, observing how the customers reacting to the process or to the product. Suggestion, focus group, interviews, surveys. You can use either electronic platforms to gather those information, like when you send a text message to the customers to fill up a survey about their experience, or you meet them in person and ask them. The voice of customers categories, either the voice of associate, that means he's working in the process, voice of investor, voice of customer, voice of process. To wrap this all, either an internal customer or an external who's benefiting from, and the internal means the one he's working in the organization, and the external, he's the one receiving the or the end user of that process. Translating voice of customers into requirements. This is, for example, what is the voice of customer? I want the pizza that I ordered. The need, right pizza to right person. That's mean you order, let's say, a pizza with the thin crust and cheese and extra chicken on it. Then this is what you should get. This is what the customer's requirement. So the requirements here, the type of requirements is accuracy. That means the order is exactly that meet my requirement or my order that I placed from the beginning. I want my pizza when you said it should be here. So if you said the pizza will be at your place, let's say 15 minutes, then he's expecting the customers that by 15 minutes the pizza should be there. So here the requirement, it's time. If the requirement or the voice of customer say, I want my delivery person to be friendly, that means he's talking about the care, about the customer relation, about complaints. So the pizza delivery person has to be polite. If the voice of customer was, I am not going to pay a lot for the pizza, that means he's talking about the price. So the price, it should be within a certain range. In all these requirements, it could be varied between customer to customer. So one customer, for example, for the price category, his range is, for example, from 20 to 40, others from 10 to 20, and so on. So this is now depend on your business. What is your market share? Are you targeting all the customers, all the type of people, regardless of their level of income or their requirements about the price, or you are targeting certain people or certain level? So the price, all the other categories, it has to be identified based on what your customers need, not your employer expectation, or not your vision. Your vision for the process, it has to be based on the or derived from the voice of the customer. There is another define phase tool, one of the tools that we just mentioned here, translating the voice of customers to a requirement, or they call it critical to quality. And here another type of tool for the define, which is the Kano model. The Kano model basically is exceeding the customer expectation to meet their satisfaction. For example, you are purchasing a car. Nowadays, it is a must to have at least an AC in the car. And this is something that is not about satisfaction. It's something, it's a must. So you see, the must, it is not going to improve the satisfaction level, but actually, if you are not going to perform, to provide it, customers, they will not be satisfied. But for the desired quality, and the desired quality means it is above than the expected. The expected something that it is ABC. When you purchase a car, you are expecting at least it is running for 10,000K without any breakdowns. You are expecting to have maybe AC, you're expecting to have radio. This is something a must. All customers, they are going to expect it for a functional cars. But the desired quality, it is something above than the expected quality. And those where it comes the features, you are expecting maybe to have smoothness, reliability for 100,000K. You are expecting to have maintenance that covered certain level. So here, as much as you increase, as much you achieve the satisfaction of the customer, but pay attention, also not providing any of the desired quality. That means you are away from satisfaction, but those are usually desired quality. It is more than the expected, but it is also something that you should care about for your customers, because it is something common. Most customers, they desired in purchasing your product or having your services. The delighted or the excited quality. This is the third part of the voice of or the requirements. For example, providing panoramic, providing auto or assistance driving, that is the car half automated. That means it could be driving by itself. So this is usually whatever you are putting here, this is beyond the customer expectation. And here is where companies try to work on having the highest market share by having more features or by having excited quality features. As much you will have customer satisfies, and that's why you see didn't know, this is the customer say, didn't know, but I like it. That means he didn't know that, or he didn't expect to have this feature, but when he tried it, he loved it. So here is the they call it the blue ocean, where you can enter the market share and have many people attracted to your products by having something that beyond their desired quality. The desired quality is something that customers, they desire it to have. As much you put from the desired quality, as much you achieve. That's delighters or the excited quality features. Those are customers, they don't expect it, but when you have it, you will attract the customers and you will make them love it, because it's something innovative, it is new. There must be, those are the standards. Those, if you are not providing them in the process, cannot increase my satisfaction, but it can decrease it if you are not going to have it in the product or the service. This is to summarize what is the Kano model. All what you need to know here at this level to know the difference between the desired quality, the expected quality, and the excited quality, or the delighters or must-be's or one-dimensional. They call it different names, but you have to distinguish between those three, because you categorize when you design your product or you design your service. After you hear from the customers, you will hear from different customers. Some customers, they agreed on desired quality to be listed, let's say 1, 2, 3. Other customers, they would add 4 and 5 and 6, and the list, it can be long. For all customers or all the voice of customers, if they agreed on 1 and 2, that's mean 1 and 2, it's a must. All customers expect to have it. So if you don't provide it, you lose your customers. And the delighters is where is the innovative part, which is customers, they don't expect it, where you can put features that beyond the customer expectation to have their satisfactions. Converting the voice of customers to critical to quality is where is the time when you convert the verbs and qualitative to quantitative, and you have it measured in a timeline or a percentage of efficiency. When we talked about the pizza example, you have to put the threshold. Where is the time accepted? For example, here, the pizza delivered on time, then the time it has to be specified clearly. So what is the target? Equal or less than 45 minutes. In the Six Sigma 46, that time it is a defect. If you deliver the pizza after 45 minutes, that's a defect considered based on the Sigma point of view. So if you put this sign, you have to be fulfill that level all the time. The specification limits, if you set it, then this is the room of the target. For example, here the specification limits 45 minutes in 100% of delivery. That's mean you do not exceed the 45 minutes as an upper specification limit. But for the lower, you can go to even 0, because this is as much as it's less, as much as it's satisfying the customer. But here the target and the upper specification limit are the same, and it is 45 minutes. It could be 40 minutes or 35 minutes, the target, and the upper specification limit is 45, and that gives a freedom for delay. But also you have to pay attention. Those minutes has to be specified based on the customer point of view, not you as a provider. This is to satisfy your customer and have a product or a service meet their requirements. The defect definition has to be clearly identified in Six Sigma methodology, and it has to be, when it turns to critical to quality, specified numerically. So delivery time, if it's exceeding 45 minutes, that is a defect in the delivering process. As well as for the delivery, you can apply that for the other voice of customers requirements that we mentioned earlier in the pizza example. And also in the slides, you will have more examples other than the time delivery. For the define phase, one of the famous tool also that to start up the project called the project charter. Project charter, it is like a template, has to be fulfilled to identify the team roles and the resources needed for the project. I will post to you an example about the project charter template, how it looks like, as well as I'm going to give you a link that I would like from you to enter it in your free time and browse it. It is very useful if you are going in the future to apply Six Sigma project, or also if you want to learn more about the Six Sigma. It's called isixsigma.com. I will send you the link now in the chat box, as well as I will also share with you the template for the project charter to see how it looks like, and also to go over it very quickly. This is how the project charter looks like. This is the template. What is the project title, the project location, the start date, the estimated end date? You see what is the roles we have talked earlier about the people who's working in the Six Sigma project. Who is the project leader, the mentor or the sponsor, the project owner, the champion? You have to identify who are they and their names. What is the problem statement? When you write a problem statement in the Six Sigma project, it has to be clearly identifying the statistical problem, as we mentioned in the first slide. You don't just write the voice of customers that they are complaining about delays, for example, in the pizza. You have to show that the number of defects or the number of complaints, and what is the average delay that, or what is the delay time, what is the target time was. So all that in the problem statement, and it has to be identified. The project description, it shows what are going to tackle, because sometimes it in the organization or in the company they have different processes, steps, or different processes linked to each other. Are the project going to cover all the processes? Some of the processes has to be clearly identified. The benefits and constraints, it has to be also identified. The team members, who are they, the limitation, what is the metric to say that it is success, the unit of that metric, the baseline for the performance. This is not has to be identically for every project, but there are different forms of project charter, but all of them serve the same goal. In the website also that I shared with you, you will see more templates, and you can see other templates than the one I shared with you here. Let's go back to our slides and continue with the project charter. So the project charter, it's a template, and sometimes it's even signed by the champion or the project or the organization leadership and the team leader for the Six Sigma project to sign off this project charter at the beginning, so they can agree even about the target, about the goals that they are going to achieve at the end of the implementation. The other tool in the define phase called the SIPOC. The SIPOC, it stands for supplier, input, process, output, and customers. We will have a room for questions. Don't worry, I will give you enough time to ask all questions after we finish the define phase. The SIPOC is the tool that break down the process in terms of identifying who's the supplier. And the supplier here, it doesn't have to be a supplier for goods. Supplier, he could be a student and an instructor. When I assign a homework to you, I'm going to be the supplier to provide you with the questions of that homework. Then, in solving the homework and return the homework back to me, you are going to be the supplier that give me the solved homework, so I grade it or I correct it. So you see the supplier, it can be changed based on the situation of the process. The input, it is, for example, of the homework, it is the homework, and the process is the homework assignment. The output is the solved homework. The customers of the process, it could be, as I said, whether internally in the process or externally. And the suppliers, whoever provide the input to a process, that's why we call it the supplier. The input is the product or data that a process does something to, or with the deliver that required the output. The process is the activity, and the output is the, again, similar to the input definition, but is the result. Here it is, you have to do it. Here it is the result. You have to distinguish between the input and output, and supplier and customer. The customer receive and the supplier provide. You have to identify those people roles in terms of understanding what is the SIPOC. There is example of the template for SIPOC here. They started in this manner, and those colored boxes here, the customer requirements, potential waste, metric. When you implement Lean Six Sigma, you add this part so you identify what is the waste and what is the metric for measuring the waste. So that's why it is common to have them with the original part of the SIPOC to measure also the waste and the unit of that waste to be eliminated. And that's why we see the Lean and Six Sigma commonly to be integrated in certain tools. Anyway, if you stop at this level here, where is the customer, it is also correct. If you add the requirement for the customer for every single step in the process, and you identify the potential waste and the metric, it is also correct. This is an example of the supplier input and process for a triage, which is emergency department. The supplier here is the patient triage staff. The input is the patient condition stage classification. The process is the triage, and the output is the critical stage or non-critical stage. The customer is the patient, whether the ER administration office secondary triage staff take him and ask for the registration, then the signs, and then examination, then consultation, then the admission or discharge. This is explaining if a person does allowance to the emergency, what are the steps or what are the set of steps starting from going to the emergency, which is the triage, until either the person admitted and go to the hospital to be in isolated or intensive care or hospitalized in the hospital, or discharge and go out of the hospital. Other examples also, you can find them in the slide. The define phase, one of the other define phase tools is the process mapping or the process flow chart. The process mapping, I think most of the students in this level in engineering in management course, they have covered the process mapping. Basically, it covers the steps of the process without mentioning who is the supplier and who is the customer. Usually just show the steps, like decide who to call, then look up the numbers, dial, then when you dial, they leave either a message for a voicemail, or they hang up, or they answer the call. This is one of the things happens when you dial to any number. So if they answer, you can have the conversation and hang up. If they didn't answer, you leave the message and you hang up, or they hang up simultaneously. So this is an example of a process flow, how it looks like. Before we go to the measure phase, I would like to have all questions to be answered, and then we continue with the measure phase. So now this is the time to answer any questions. Please use the mic or use the chat box to ask your questions. Okay, a question says how I decide the project, whether it should be a black belt or green belt project. Now, it is based on the project scope, based on the agreement of the company, that whether are going to have people hired or in their organization to be mastering or supervising the projects. For example, you could have a mega project, big one, that has sub-projects. So you need a black belt or master even black belt to supervise those projects together. But also you could have one small project that it doesn't need to have all those roles we have mentioned. As we said, this is the ideal case when you have several projects going in the company, or if the company is adopting those roles to be part of their job titles. So whenever they need to implement Six Sigma, there is master black belt position. As I told you, in some companies, there is a black belt trained people and certified. There is a green belt certified. So those, they will be from the company. But if you are going to have people out from the company to be doing the project, it will depend on how big is the project and how is the complexity of the project to need the level of the black belt or the green belt. The black belt, it can deal with several projects, can coach. He is familiar with the advanced statistical methods, design of experiment. He is able to perform design for Six Sigma, not only DMAIC. he is experienced in implementing several projects before to be certified as a black belt. So it depends on the project level. What other questions before we move on? Okay, seems these are the questions we have. We will move on to the measure phase. The measure phase is identifying and collecting the data needed for the project to measure what is the level that is, or what is the current level is the process is performing. The type of measurements, we will have them here in the next slide, either a quantitative or qualitative. The quantitative like length, size, width, or qualitative, I think the slides here, it has to be presented in the PowerPoint because there is additional slide underneath this one, but I will post this later to you. We will have the descriptive data like the attribute data that you all familiar with from the statistics course, or the continuous data. For the quantitative data, that you are going to use mean, median, mode, quartile, standard deviation, variation, range, to measure the spread of variation. You use those tools. If you are going to use this tool to see what is the central tendency, and these already covered in the statistics course. What is not maybe covered previously, the measurement system errors can be due to one of those things. And what does mean the measurement system errors? The defects that's happening when you gather the data, what is the causes of those defects? The accuracy is one of the causes. That means the difference between the average of the observed values and the standards. That means the data, if it's not meeting the standards that you collected, that means the observed data is not accurate as the standard. The repeatability, the variation in measurement when a person measures the same unit repeatedly with the same measuring gauge. That means when a person, he is doing the same measurements, he's using the same tools, but when he do it repeatedly, he doesn't get the same value every time. So it is based on the repetition is not meeting the exact standards every time. The reproducibility is the variation when two or more persons measure the same unit repeatedly with the same measuring gauges. The difference between reproducibility and repeatability, the repeatability is the same person, the same measuring tools. The reproducibility is different persons, but using the same tools. The stability is the variation in measurement when the same person measured the same unit using the same measuring gauge over an extended period of time. That means if you are not going to do the measures repeated simultaneously, but you will have extended time to do the measurements, then they are variating. That is called the stability. This application is not stable, or one of the causes is the stability that you are having the variation. The linearity is the consistency of the measurements across the entire range of the measurement gauge, and that is referring to the tools more to the humans. So when you gather data in the process and you find a variation, the causes of the variation, it comes from one of those 5 types, whether accuracy or repeatability or reproducibility, stability, linearity. Those are the causes of the variation in the measure phase, so you have to pay attention to them. The process variation causes either a common causes or a special causes. Common causes like inherited of process when being stable, that's mean you have let's say average performance between employee or between staff to staff, but within the specification limits. So the differences between them, this is a common causes for variation, but the special causes, this is unpredictable, and usually it is exceeding the specification limits. If it's exceeding the specification limits, then that's mean it's a special cause. There is something wrong. The machine broke down during the process. The person you hired, he's not trained at all, so he doesn't know how to operate. So this is the process variation causes. Here is the source of the measurement errors. What are the source of measurements? And here is the source, the process variation causes. The data interpretation is the stability or normality or shape of centering. And this is when we come to the control charts, you will see them clearly. The stability, analyzing using run charts to check for the patterns. The normality, using normality standard, normality central limit theory to make sure the data is normal. The shape, whether it's a binomial or histograms or bar chart, all these shapes, it will demonstrate to you the type of data. We covered, or in the statistics, you covered those charts, for example, to check the normality. You have normality test, or you can use a histogram to show you that whether, for example, here you have a binomial clearly in the data, or you have it skewed to the left or skewed to the right, or normal distribution where you see the bell shape, you can draw it on the histogram. And also this is checking for normality, and you can tell here there is a curve to up and curve to down. That's representing also the binomial on the data. Measuring phase tools also is the process capability. Those, by the way, some of those tools are going to be covered in the future in specific chapters. Like the process capability, there is a chapter where it covers the process capability in terms of the mathematical formula for the process capability. Some of those tools already covered in the statistics, like the histogram and other bar charts or pie charts or so on. So we will cover most of those tools, inshallah, later in other chapters. But here it shows you how the Six Sigma, it is for each phase, what are the common tools to be used. Here, for example, the process capability, to make sure whether the process is capable to perform and achieve the objective of its goals and give you the output that you desired. There are a formula to calculate the process capability called the Process Capability Index, CP and CPK, which we will cover it later, inshallah. The process sigma, this is one of definitely the major tools. You have to calculate the sigma level to find what is the quality level in the measure phase, so you know what is the baseline you are going to use and improve. The sigma level, you have, in order to calculate it, you have to use the formula, the Dpmo, which stands for defect, which is D. P is the opportunity, peer, and million is the M. O is the opportunity. U is the unit. Item being processed, for example, the pizza order, that is a unit. The defect is the failure to meet the customer requirements, like you exceed the time for the delivery. If the process was only for the delivery, but if you are going to focus on all the other requirements of the customer, then the defect has to be identified for every opportunity. And here is where the O comes. If the opportunity of the defects defined by the customers, the defect that is 4 things, let's say, we mentioned them before: the time, the price, the person who's delivering, how he is polite, and let's say the exact order that you ordered. So those 4 different type of opportunity, at each one of them there is a defect could happen from the customer point of view. The time, if it's exceeding 45 minutes, then the time or the opportunity for the time considered to be 1 opportunity. And the delivery guy is polite, this is another opportunity. If we have the exact order, this is a 3rd opportunity, and the 4th one is the price. So we have 4 opportunities only for the pizza process from the customer point of view. At each opportunity, you may have a defect, and that defect is specified numerically and clearly by the customer. So you have to identify those first in order to calculate the DPMO, which is the defect that happened in the process divided by the opportunity times the unit, all times to 1 million to get the DPMO. After you get the DPMO, you can go to the tables here that we have showed earlier. And also in the website, you can find a Six Sigma or the Sigma level calculators that calculate the Sigma level for you. I will send you another link for the Sigma level calculators. When you calculate the DPMO, you just track it here and see what is the Sigma level that you are performing on, and to know what is the percentage or yield of the process. I will give now a time for questions for define, measure, and the phases that we have covered, while I'm going to do a random attendance and post to you a Sigma level calculator link, so you can see how you can calculate the Six Sigma, the Sigma level of the process.